Execution failure begins when an unresolved state becomes executable. Why operational residue matters at the execution boundary. When a complex system fails, the explanation that follows is usually a story about an error. A wrong calculation. A misconfigured setting. A missed condition. A bug. A human mistake. The narrative locates the failure in a specific, identifiable cause. The cause is named, addressed, and added to the list of things the next version of the system will guard against. This narrative is useful, but it is incomplete. It overlooks a different kind of failure, one that does not begin with an error. It begins with something that was technically valid, was once correctly approved, and was simply left unresolved until the moment it became executable. This is the fifth entry in FO Lens. It examines the relationship between unresolved state and the execution boundary. Failure does not always start with a mistake. Some failures start with a clearly identifiable error. A signal fires when it should not. A condition evaluates incorrectly. A piece of code does what it was not meant to do. These are the failures that incident reports are good at describing. Other failures start with something that was correct when it entered the system, became less relevant over time, and was never closed out. The old approval that no one revoked. The temporary permission that was granted for a specific purpose and never withdrawn. The configuration that was correct for the previous version of the workflow. The credential that was issued for an integration that no longer exists. The exception that was made once and quietly remained as a precedent. None of these are errors. Each was a legitimate decision at the moment it was made. They are not bugs to be fixed. They are unresolved states, pieces of operational history that were not formally closed and were carried forward into a present that no longer matches the conditions of their creation. For most of their lifespan, unresolved states are inert. They are not actively wrong. They are simply not actively examined. The problem appears when one of them becomes executable. 3 forms of unresolved state. Unresolved states do not all look the same. 3 forms appear repeatedly in operational systems. Stale authorization. An approval that was valid at the time of granting, but whose conditions have changed, whose grantor has lost the authority to grant it, or whose intended scope has narrowed in ways the authorization record does not reflect. The authorization still resolves as valid when checked, because the system does not know it has gone stale. Latent permission. An access right that was granted for a purpose and remains in place after the purpose has ended. The user moved roles. The integration was decommissioned. The vendor relationship lapsed. The permission record persists, available to whatever process can reach it. Drifted assumption. A configuration, policy, or operational assumption that was correct when it was set, and that the surrounding system has moved away from. The action that would have been safe under the original assumption is no longer safe under current conditions. The assumption is not flagged because it was never marked as time-sensitive. These 3 forms share a structure. Each was correct at its origin. Each remained in the system. Each became dangerous not because it changed, but because the world around it did. Why this is not a hygiene problem. It is tempting to read unresolved state as a hygiene issue, something that better record keeping, scheduled audits, or periodic permission reviews could resolve. Each of these helps. None of them is sufficient. The reason is timing. Hygiene operates on a schedule, quarterly review, annual audit, periodic cleanup. Execution operates in the moment. An unresolved state can pass 3 quarterly reviews and still be in place when the action that activates it opens. The interval between hygiene cycles is exactly where the gap lives. This is not a criticism of hygiene practices. They reduce the surface area of unresolved state and they catch many problems before execution. But they cannot, by their nature, intercept the specific moment when a particular unresolved state becomes executable. That moment is what Hygiene is not built to catch. The interception has to happen somewhere else. It has to happen at the boundary where the unresolved state attempts to become an action. The boundary is the checkpoint that must see the present. At the execution boundary, the system has access to something Hygiene cycles do not, the present. The actual current state of authority. The actual current state of the target system. The actual current state of conditions and dependencies. At that moment, the system can ask a question that Hygiene cannot ask retrospectively: is this action, right now, still admissible? If the action is being authorized by a stale authorization, the boundary can detect that the authorization does not match present authority. If the action is being enabled by a latent permission, the boundary can detect that the permission's original purpose no longer matches the present request. If the action is being executed against a drifted assumption, the boundary can detect that the assumption no longer holds in the current conditions. The boundary does not need to know the history of every unresolved state in the system. It only needs to evaluate whether the conditions for this specific action to open are met in this specific moment. This is the structural advantage of execution time evaluation. It does not require complete knowledge of the system's residue. It requires a check against present admissibility. What this implies about failure. The pattern that emerges from unresolved state failures is consistent across domains. The failure does not begin with the moment the unresolved state was created. By then, no one knew it would become a problem. The failure begins with the moment the unresolved state became executable, when the world had moved enough that what was once benign was now consequential, and the system opened the action anyway because no checkpoint was positioned to notice. This reframes what failure analysis is looking for. The question is not only, what went wrong? The question is also, what was allowed to become executable when it should have been re-evaluated? The first question identifies an error. The second question identifies a missing boundary. Both questions matter. But the second points to a different kind of structural fix. Errors are easier to talk about than residue. An error is identifiable, locatable, and assignable. Residue is diffuse. It does not have a single moment of creation, a single cause, or a single owner. It accumulates. For this reason, the failures that begin in residue are often classified, after the fact, as errors. The incident report names the closest identifiable cause. The cleaner explanation is preferred over the more accurate one. But the more accurate explanation, in many cases, is that something that should have been closed remained open, and something that should have been re-evaluated was not, and the action opened against conditions that no one had recently examined. Execution failure does not always begin with a mistake. It begins with an unresolved state that became executable.